Hey yo, 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 hey yo, hey yo. Hey everyone. In this video, we're going to be talking about some equations with the variable on both sides of the equal sign instead of just on one side. So we still have some key terms here, inverse operations and combining like terms. Yes, I'm sure that you have seen these before, but get them down again because they're so important. Inverse operations are our opposites, the ones that undo each other. And combining like terms is when we combine terms that have the variable with the variable and ones and our constants with constants. So let's just get into this though. So we're going to solve equations that look like this. So we have x plus 5 equals 3x minus 1. So what we have here is we have an x on the left side and an x on the right hand side. Okay, so I have the variable on two sides of the equal sign. So our goal when we solve equations is to get the variable by itself. But the problem is what people have is they don't know which variable to get by itself. Do I want to get this one by itself or this one? Well, the thing is I'm trying to solve for x. So the x on the left side of the equal sign it represents the same number as the x on the right side of the equal sign. That's why it's the same variable. So what we want to do is we want to get it to the same side of the equal sign and then combine like terms. So it does not matter which direction we move it in. So what I mean by that is here's my equal sign right here. Whoops, I got that in white. No, white, I want red. Sorry. Here's my equal sign. So what I want to do is I want to cancel out either x or I want to cancel out 3x on either side of the equal sign and move it over. So the way we do that is we do that by doing the inverse operation or we do it by subtracting or adding, basically. So what I mean by subtracting or adding is I want to move this entire term or I want to move this entire term and I want to move it over to the left or I want to take this one and move it over to the right. It does not matter which way we go, we'll get the same answer either way. So what I mean by that is let's say I said I like having my variable on the left side of the equal sign. So I want to move all of this 3x over to the left hand side. I'm not going to divide by 3 because if I divide by 3 I have to divide everything, but that doesn't make the x go away. The x stays over here. And I know dividing by 3 is how we would cancel out the 3, but I want to move the entire 3x. So the way I move the entire 3x is I'm just going to subtract 3x. And the reason why I can do that is 3x minus 3x, when we were learning how to combine like terms before, well, that's 0. They cancel each other out. That's the point. But if we follow our rules with equations, whatever we do on one side of the equal sign, we have to do on the other side. So because I'm subtracting 3x on the right side, I have to subtract 3x on the left side. But when I subtract 3x on the left side, I can only subtract x's from other x's. I cannot subtract 3x from 5 because they are not like terms. So x minus 3x is, because this is, whenever there's an x, it's really a 1x. 1x minus 3x is negative 2x. Bring down my plus 5, bring down my equal sign. Nothing's happened with this negative 1, so then I bring that down. Now if you look, I'm back to a two-step equation. And then I would solve like how we've solved in the past by getting rid of my constant first, bringing down my negative 2x equals negative 6 divided by negative 2, and I would have gotten x equals positive 3. Now, x equals 3. So if I were to plug that into my original equation, so my original equation was x plus 5 equals 3x minus 1. If I were to plug in 3, so that's 3 plus 5 equals 3 times 3 minus 1. That gives me 8 equals 9 minus 1 is 8. So it works. Okay. Now, I do want to show you though, if I wanted to solve this the other way, I'd get the same answer. So here's my original equation again. Let's say I wanted to instead move the variable to the right. So instead of doing subtracting 3x from both sides, let's say I decided to subtract x from both sides. And this is actually what I would probably do anyways. Because what I like to do is I like to look at it and to see which one do I move over is going to give me a positive coefficient. Because I like positive numbers. See here we have a negative coefficient. I'd rather have it be positive. And I can realize if I just subtract 1x from both sides, I'm going to have positive 2x. And normally that is a little bit easier to work with because a lot of us still make mistakes with our positive and negative signs, and so it prevents that from happening. And you'll notice I still get x equals 3. So it doesn't matter how you choose to solve it, which variable you move over, you will get the same answer either way. I prefer to do it this way. I would rather move generally the smaller number from the larger number, subtract those or add the smaller number to the, anyways, but I would rather do that, whatever's going to give me a positive coefficient. Okay. We got 3 to practice, so don't worry. So on this one right here, let me make this a little bit bigger for you guys. I'll just roll up. So on this one, I have to write the equation first, and then I get to solve it. So let's start figuring out how to write the equation. Andy's rental car charges an initial fee of $20 plus $30 per day. So initial fee, I'm going to write Andy right here. Initial fee, so that's $20 up front plus $30 per day. We know that word per day means multiplied by however many days. So that's good. Now we have Buddy. So good old Buddy's rental car. I'll do Buddy in purple. He charges an initial fee of $36 plus an additional $28 per day. So there's $28 per day. So there's an expression for Andy, there's an expression for Buddy. For what number of days is the total cost charged by the companies the same? So I want to know for how many days, days is what I used to represent, I use the letter D to represent. So how many days is it going to take for this to be the exact same cost as this? So I want to know when will the left side be equal to the right side for how many days. So there's my equation. 20 plus 30D equals 36 plus 28D. So then now what I need to do is I have to solve it. So I need to subtract. I have D's on the left and D's on the right, so I have to subtract and move them over to the same side of the equal sign. So I could subtract 30D or I could subtract 28. I'm going to subtract 28 because it's going to leave me a positive coefficient. Because that makes that go away, that's 0. And then this is going to leave me with 2. And then break everything else down. Now, I just get to subtract and solve my two-step equation by doing the inverse operations. And this is why showing all your steps is so important, because it makes these equations super simple. And I would get 8 days. So we could see if that makes sense. Are these going to, as 8 days, is it going to be the same exact price for each company? So with Andy, if I were to plug in 8 days here, $30 per day, 8 times 30 is 240 plus 20, that gives me 260. For Buddy, I would do 28 times 8. Let's see, that's 224 plus 36. Oh, look, I get 260. Cool. So I did it right. So that means that 8 days, each company is going to cost $260. Okay. Go ahead and pause, and I would actually try both of these. So I would try the word problem, write your own equation, solve, and then I would also try the other one on your own and see how you do. So water tank holds 256 gallons, but is leaking at a rate of 3 gallons per week. So it's starting at 256 and it is leaking, meaning it's losing water. So we're going to subtract 3 gallons per week. I'll use W for weeks. The second tank holds 384 and it's leaking 5 gallons per week. I want to know how many weeks will the amount of water in the two tanks be the same. So I want to know when they're going to be equal. There's my equation. So again, this is where we get to look to see which one do you want to move over. It does not matter, but my personal choice, I would choose to add the 5W. And the reason why is that's going to turn this from negative to a positive. Because negative 5W plus 5W does make 0. but then negative 3w plus 5w is 2w. And it is a positive 2w, so that's going to change this from subtraction to addition, and the reason why is because negative 3 plus 5 is positive 2. That's equal to 384, and then now I get to solve my two-step equation by getting rid of my constant first, doing some subtraction here, bring that down. Let's see here. Oh, I forgot to draw my line down here. Sorry about that. 384, so I got to borrow. I get 128, and then divided by 2. And I would have gotten W equals 64. So that means in 64 weeks, these would both be the same. Okay. Good. Now, let me clear this out. For this second one right here, again, we want to get our variable to the same side. I would add 3x to both sides. Because negative 3x plus 3x is 0, but negative x plus 3x is positive 2x. I think we've gotten 2 as a coefficient for each one. That's a coincidence, just so you know. That should not always be the case. So now I solve my two-step equation, so I would add 8 to both sides. Looks like I'm going to get x equals 5. All right, and that's it. So big thing is just remember, get the variable to the same side. Okay, so move it over to the same side, and it doesn't matter which one you move over, but cancel out the entire term by moving it over to the same side. Okay, and then once you do that, you just solve the equation like you've always done, and it doesn't change anything else. So give me something down and things to remember, whatever you think is the most important things to remember. Do not forget writing something down in there, and then do not forget, and then make sure you do both of the independent practice problems and the exit ticket, and that's all I got for you guys today. So thank you for watching. If you have any questions, please let me know. And that's it, guys. Grudius out.